Hola clase! In this video we are going to learn how to find the optimum solution for a system of inequations. And I'm just realizing that the title got a bit cut, for which I apologize, but I'm pretty sure everything else fit in the frame. Now the optimum solution is the one that maximizes or minimizes a specific function within the range of the feasible region. So before I'm starting, I need to know that parallel lines all have the same gradient. I need to know how to represent all the possible parallel lines, which is a function that it looks like f equals ax plus by plus c. Remember that a, b, and c are coefficients, they represent numbers. I need to know how to evaluate a function and to graph linear equations. Now for the how-to step by step, the first step is always to graph the inequations to find the feasible region. After that, I can find the vertices of that region, which are going to be the intersections. And I can do that algebraically, solving simultaneous equations, or I can do it using a graphing program, which is what we're going to do. After we've got them, we want to evaluate the function at the vertices, and the optimum solution is going to be one of the vertices. Let's see that on an example. Here they ask me to find the point that maximizes that function f equals y minus 7x in the feasible region defined by those system of inequations. So the first step is going to go to our graphing program. We're going to use GeoGebra. I go to the graphing calculator and I graph those inequations. I've already done that because we've got a video on how to do it. But if now I want to find the intersection between two of them and click, I see that GeoGebra doesn't find anything. And it's because the intersection of two inequations is not a point, it's actually a whole area. So there is a trick around that, in which I'm going to graph the boundaries, the equations, the straight lines that are in the boundary between when the inequation applies and doesn't apply. So it's as simple as going to our commands or to our algebra tab and retyping the system of inequations as equations. So I'm just going to type the first, second, and third ones, and instead of the inequity, I put an equal. As you see, nothing changes because those were already graphed in the graphing area. But now if I try to go and find the intersect, I position myself close to them, and now I see it labeled there. If I go back to the commands, I see that that point A is labeled as the intersection between the two equations with this set of coordinates, 1, 4. So now I can go, repeat the same. Remember, it's good to have a system, so we always go either clockwise or counterclockwise. But if I do that, I just ask for the intersect, put myself close enough, and I see them labeled as B and C, and that gives me the coordinates of all these, in this case 3, vertices of the feasible region. Now that I've got the vertices, I can go and evaluate. So basically, each one of these 2 points has an x and a y coordinate. So I can ask which is a function of, for example, a, which is the first one, which is substituting the x and the y coordinates in the function. So if I do the first one, it could be 4, y is 4, minus 7 times 1, in this case x is 1. If you do that, now I can do the operations, it gives you minus 3. If I do exactly the same thing for b, the function of b is going to be 1 minus 7 times 2.5. If you do that, that gives you minus 16.5. And the function of c, substituting it, could be 1 minus 7 times minus 5. That gives you 36. So out of the 3, 36 is the highest value, which means the optimum solution is going to happen at point C, which had that maximum value. The last step is going to make a statement so I can show very clearly what is my answer. And we can write that the function is maximum at that point, minus 5, 1, with a value of f equals 36. And we can always follow that format to give our final statement, and it will work, given the point and the value that makes it maximum. Now it's your turn to go and practice. Thanks for watching.